So in today's video, chapter 4, section 2, we're going to graph rational functions. So when it comes to graphing, we're going to do all the things we did when we were first given an equation or a function back in 4.1. We basically looked at the expression, we simplified it to identify any holes. We found our asymptotes. In addition to those things, we're going to find our zeros, which you know are our x-intercepts. We're going to find our y-intercepts. And then we're going to pick points and graph. And by picking points and graphing, that part of it, we're going to be using our calculators for. Okay, so we're not going to calculate any x and y combinations ourselves. We're just going to look at our table on our graph and kind of plot a couple of points. We're going to get the general curve, and we're going to draw it out. So when I come to this graph, I'm going to look, or this function, and I see 3 over x minus 2. I'm not going to type that into my calculator yet. I'm going to start to identify the different parts that we discussed in the last slide and really in the last section. I'm going to look at this and I'm going to look for holes, right? I don't have to do one, but basically I'm going to be looking for some holes here. And I realize there's nothing repeated in the top and bottom, so there's no holes. The second thing I'm going to look at are my asymptotes. And so I'm going to look for my vertical asymptotes first by making my denominator equal to 0 and saying that x equals 2 is my vertical asymptote. So I can start with that. I can come over here and the line of x equals 2 would be this line here. And so I know my vertical asymptote is going to be this line, right? That's the line that my graph is not going to cross. Then I go to my horizontal asymptote, and remember that this is like x to the 0, this is like x to the 1, and when the degree of the exponent is greater on the bottom, you know that you have a y equals 0 horizontal asymptote. And so really my horizontal asymptote is this line here, which is really the x-axis, okay? And so that's the line of y equals 0. So now we're going to think about our x-intercepts and our y-intercepts. Remember that your y-intercept is found by making x equal to 0, right? So 3 over 0 minus 2 or negative 3 over 2. So our when x is 0, y is negative 3 over 2, which is negative 1.5. So again, I'm going to come over to the graph, 0, negative 1.5 right here, and there's my y-intercept. And then the next one is my x-intercept, which is my zeros. Remember that basically that means setting my entire equation or function equal to 0. Now, if I just think of this, if I want to solve this right, I could multiply both sides by x minus 2 over here, x minus 2 over here, and I get 0 equals 3. Which doesn't make sense, right? That means there's no x-intercept. And again, I know there's no x-intercept because notice the x-axis is actually my asymptote, which means my graph is not going to touch the x-axis, which means I'm not going to have an x-intercept. But again, mathematically, that's how you might see it, okay? And so now I have everything I need. All I need to do is plot a couple points, and I'm able to graph this. So at this point, you're going to type this into your calculator. Probably you already have. I would probably start by typing it into your calculator and getting a general idea of what it looks like. When you go to type it into your calculator, something like this, I would do 3 divided by, and then in parentheses, I would do x minus 2 like that in parentheses. If you don't put the parentheses, it might mess it up. And when you get your graph, you're going to notice your vertical asymptote is there. And you're going to see that your graph has kind of like this weird little curve, which is exactly what you sort of envision, but now you know. So what you're going to do is you're going to go to the table and you're just going to write a couple of values. So when I go to my table, I get 0, negative 1.5. Well, I already knew that one, right? I'll do another one. I'll do at positive 1, x is negative 3. So there's one value. At positive 1, x is negative 3. And I'll go back and I'll do negative 1. And at negative 1, y is negative 1. So when x is 1, y is negative 3. When x is negative 1, y is negative 1. And that's enough. That's going to be enough for me to be able to kind of recognize that this side of the graph is going to look like that. And now I'll go into this section, which is where the other part of my graph is. And so I'll do, for example, when x is 3, y is 3. So 3, 3. So 3, 1, 2, 3 here. I'll do 4. When x is 4, I'll get 1.5. So 4 and 1.5. So 4, 1.5, like that. And that should be enough as well for you to recognize that your graph will look something like this. Now, if you notice, there is an error drawn on the graph. When x is 2, you get an error. That error message is because that's your asymptote, right? That's where the error message is coming. There is no y value at x is 2 because it's the asymptote. And this is enough to graph. You have a few points, gives you an understanding of the curve, and you found all your important values. And that's really all you need to do. So now we come to our second problem, and we're going to do all those same things. And so again, I'm going to first try to figure out, are there any holes? Well, my graph is fully factored. There's no repeated factor top and bottom, so there's none. Okay, so there's no holes. Then I'm going to go to my vertical asymptote, and I know that my denominator cannot be 0. So my vertical asymptote is the line of x equals 0, which means it's the y-axis is my vertical asymptote. Okay, so x equals 0. Then I go to my horizontal asymptote, and again I notice this is x to the first, and so my horizontal asymptote is going to be those coefficients in front of that. So it's going to be 2 over 1 or 2. So it's going to be y equals 2 over 1, or the line of y equals 2. So y equals 2 looks like this. And that's my horizontal asymptote at y equals 2. So no holes, vertical asymptote, horizontal asymptote, and now I'm going to find my intercepts. So I'm going to start with my y-intercept. And again, remember that my y-intercept is when I make x equal to 0. And notice that I'm going to get an undefined problem here because I cannot have a 0 in the denominator. And that makes sense. There is no y-intercept because if you notice, the y-axis, which is where the intercept would be, is an asymptote. So there is none in this one. So we're just going to say no y-intercept. X-intercept, again, we're going to make the whole thing equal to 0. Now, when I do the math here, I multiply both sides by x, right? X and x. I get 0 equals 2x minus 1. 1 equals 2x. And if I divide everything by 2, I get x equals a half. So my y-intercept is going to be located at x equals a half. Or my x-intercept, rather, is going to be at a half. So it's right here. Okay, so when x is a half, y is 0. So I can write it as 1/2, 0, like that. And so I have my intercept. Now that I have all these values, the vertical, asymptote, horizontal, the intercepts that are there, I'm able to then just go to my calculator and actually find some additional points. And when you type it in and you look, again, everybody should start by typing it in. Again, when I typed it into my calculator, I did 2x minus 1. I did it in parentheses divided by x, and that's how I got my graph. And when I notice, I see that at 0, my y value is an error, which again, that tells me that that's one of my asymptotes. Anyway, so I'm going to keep going, and I get, I'm going to look here, and I say, okay, when x is 1, y is 1. When x is 2, y is a half. So let's see, when x is 1, y is 1. That's one good value, okay? And when x is 2, I get y is 1.5. Like that. So when x is 2, so I already know my little curve, and I know my curve is going to go like this up to the asymptote and over this way, and then I could go into the other one. So when x is -1, I get y is 3. So -1, 3, and then I'll do one more number. I'll do -2 and 2.5. So -2 and 2.5, and so I know it's going to get closer to this asymptote and it's going to approach this one. And so that's my graph. And so again, I really have -2, 2.5 like that. So again, these come off of your calculator in the table. And so you want to know how to use your table because that's going to save you time. You calculate the whole, the asymptotes, the y and the x-intercepts, and then you let the calculator kind of tell you the rest. So again, now I'm going to type this again. You should be typing this into your calculator. You're going to do x divided by, and you're going to do x squared minus x minus 2. You're going to kind of get an idea of what this should be looking like. And when you look at the graph, you're going to see this one looks a little bit weird, right? It's very hard to distinguish when you look at the graph at first. So let's try to identify some important parts, and I think it'll be clear. So again, are there any holes, right? So let me just first simplify this. This is an x minus 2 and an x plus 1. And notice there's nothing on top that's repeated on the bottom. So there's no holes here, okay? Then we go to our vertical asymptote. And remember, our denominator cannot equal 0. So x minus 2 can't equal 0, which means x equals 2 is one vertical asymptote. And x plus 1 can't be 0, which means if x is -1, it would equal 0, and that can't happen. So again, I have my two vertical asymptotes. So if I come to the graph, I see that I'm going to have one vertical asymptote at -1, and I'm going to have another vertical asymptote at x equals 2, which can absolutely 100% happen. Okay, you can have multiple vertical asymptotes. So then we're going to look at our horizontal asymptote, and when we go to the equation original, we see that there's an x to the first power at the top, an x to the second at the bottom, and what we focus on is the bottom one is greater, which means our horizontal asymptote is y equals 0. Remember, this is something we memorized in 4.1. Okay, so this is my horizontal asymptote is right there. So at this point, I'm going to look for now my x and my y intercepts, right? So I'm going to start looking for my, I'll start with the y-intercept. I think that one's always easier. My y-intercept, I'm going to make my x's all equal to 0, right? So 0 squared minus x minus 2, or minus 0. So it's going to be that which is just equal to 0. So my y-intercept is 0. So when x is 0, y is 0. So when I come to my graph, 0, 0 is a point on my graph. Okay? My x-intercept is when I set the entire function equal to 0. Now, this one's kind of interesting, right? I have that variable up in the numerator spot. And what happens is for my function to equal 0, my denominator can't equal 0 because that makes it undefined. What's really important is my numerator has to equal 0. When my numerator equals 0, 0 divided by anything is 0. And so all I really have to do is make the numerator equal to 0, and that's going to be my x-intercept, okay? So, so I would do 0 equals x. So when y is 0, x is also 0. And so notice 0, 0, the origin is also my x-intercept. The origin is actually both my x and my y-intercept. So that's done with that. Okay, so now that I have that, I'm ready to graph it. And when you look at your graph, it really looks confusing. So if you go to the table, it's really going to help you out significantly. First of all, you should notice in the table that -1, an x of -1 and an x of 2 give you an error message because those are your asymptotes. So I'm going to do, I'll start here, and in my graph, I'll start with when x is 1, y is -1/2. So when x is 1, it's -1/2. So that means that it's here, right? And I'll do, that kind of makes it a little bit difficult to see, but it's basically going to be a graph that's going to go like that, and it's going to go like that, okay? If you change the table to like halves, you'll see some more points. Mine is just integers, makes it a little tougher. Okay, and then I'm going to say, all right, when x is 3, where is my graph? Well, when x is 3, y is 3/4. 3 is 3/4, right? So when it's 3, it's 3/4, which is about there. And I'll do a little bit bigger. Let me try. When it's 5, it's almost 1/4. When x is 5, it's 0.27 something. So it gets closer to 0. Okay, so it's going to be like that. It gets smaller and smaller and smaller. And then on the other side, if I come over here, let's say -2, when x is -2, it's -0.5. So -2, -0.5 there. No, that's kind of weird. And let me try -4. Let's try that number. Or even let me go bigger. -5. When x is -5, y is -0.17. So it's closer to 0. So this is really 1, 2, 3, 4, 5. And it's closer. So again, really difficult. You just have to say, is it as the x, gets -5, -6, is it getting closer to 0 or further away from 0? And then you can kind of see your wave. And this is enough. So again, as long as you give me a few points in each sector, then I know that you know the general wave. And again, the graph can help a little bit or a lot on this. Okay, so we come to a new graph, and again, we always have to simplify here to identify holes. So when I'm doing the holes part of this, I know my numerator is x plus 3 and x minus 3, and my factor denominator is x minus 3 and x plus 1. As soon as I see that I have this repeated factor, I'm going to simplify it, but I know that that repeated factor is going to affect that there's the fact that there's going to be a hole. So I know the x value of the hole is going to be +3. And when I plug that into the simplified version, I'm going to get 6/4 or 3/2. And so I know the location of my hole is at 3/2. Next, I'm going to look for my vertical asymptote, and I know that I'm going to use the simplified version. So because I know that x plus 1 can't equal 0, I know the line of x equals -1 is going to be my vertical asymptote. I know my horizontal asymptote. I'm going to look at my original, and since both of them have the same exponent of 2, I know it's going to be the line of y equals the coefficients in front of those, which is 1/1 or just 1. So y equals 1 is my horizontal asymptote. Okay, so we're going to now we did our vertical asymptote, we did our horizontal asymptote. Now we're going to do our x and y intercept. So for our x-intercept, we're going to make the entire function, right, equal to 0. Now, you need to use the simplified version. So it's going to be x plus 3 over x plus 1. Again, you're going to multiply x plus 1 to both sides, and you're going to get 0 equals x plus 3, which means x equals -3. So -3, 0 is our x-intercept, and our y-intercept, you're going to make the x is equal to 0. And again, use the simplified one because it's easier. 0/3 and 0 plus 1, so that's 3. So when x is 0, y is 3. So again, for most of these, you're going to use the simplified one. Only the horizontal asymptote do we really kind of go back and use the original. And I believe the simplified one would even give you the same answer. But either way, now you have all these points that you now have to plot on your graph. So now we start out with, let's say, our vertical asymptote, x is -1. So here's my vertical asymptote, x equals -1. We've got our horizontal asymptote, y equals 1. Do this little dotted line here for my asymptote. That's my horizontal asymptote. I know that I have a hole in my graph at 3, 1, 2, 3, 1.5 right there. I go to, what else do I have? My x-intercept is -3, 1, 2, -3, 0 right here. It's my x-intercept. And my y-intercept is 0, 3 here. Okay, and so now these are all the important points, obviously, and the critical asymptotes here. I do my asymptotes as dotted lines. You don't have to. You could do them as solid lines if you prefer. They don't have to be dotted. I don't know why I do it. But anyway, those are my asymptotes, those are my points, those are my zeros. And if you go to your graph, you pretty much get the wave of what the graph should look like. Now, what you're going to notice is the first thing should jump out at you is you don't see this hole in your graph. But you will see it in the table. If you were to go to the table at x is 3, you're going to notice that you get an error message. That's because it's a hole. You get an error if there's an asymptote there. You get an error if there's a hole there. So again, you're just going to plot some points. You know, you need to kind of know those, but then you're just going to plot some points. When x is 1, y is 2. So when x is 1, y is 2. And that's enough for me. I mean, I think you can do this part of your graph pretty easily. You know, not the best way, but it's good enough. And then you're going to go to the other side and you're going to plot a couple of points over there to kind of make your graph a little better. So let's say when x is -2, y is -1, you're going to get this off of your table. So -2, -1. And again, that's a number 2, I think, because you know it's going to go down here and you know it's going to go up and closer to there. And again, when you just go to your graph, you can kind of see that layout. You see your vertical asymptote. And I think that's it. And that would be it. So again, we just keep doing more of the same, all of it the same process over and over again. So again, you're going to come over here and you're going to simplify it first to identify any holes you might have. So you get x minus 1, and over here you have an x plus 1. And so you're like, okay, nothing's repeated, so there's no holes. So no holes for this one, okay? Then we go to our vertical asymptote by setting our denominator equal to 0 and finding that x value. That's my vertical asymptote. I go to my horizontal asymptote. I see my exponent up top is larger than my exponent on the bottom. And so that means there is no horizontal asymptote. Okay? And because this one is 1 more than the one below it, this is the first power, 2 is 1 more than that, what we're going to have here is a slant asymptote. So if you remember, what you're going to end up doing on this one is you're going to take the numerator and you're going to divide it by the denominator. Do you remember doing that? So you're going to come over to here and you're going to do x squared plus x minus minus, cancels, you're going to get minus 2x. You're going to bring down a 0, and you're going to figure out, keep dividing, you do minus 2, and at this point you can really stop. All we really wanted to do was get to the point where we got this in y equals mx plus b form. That is your slant asymptote. It is the line of y equals x minus 2. So before I continue with my intercepts, let me show you what all this looks like on the graph. We come over here, vertical asymptote, x is -1. I'll even do a straight line instead of a dotted line. So here we have x equals -1. That's my vertical asymptote. My slant asymptote is the line of x equals -2. Well, if you're graphing that line, you know that you have a point at -2 and a slope of 1. So if I just kind of do a couple of dots and you know, in either direction, I know that my slant asymptote is this line that connects these dots. Okay, and so this is my slant asymptote. This is the line of y equals x minus 2. So now I'm ready to kind of figure out, okay, I know where my lines can't cross, right, or my graph. What does my graph look like then? Well, let's start with the let's try our y-intercept. Remember, we're going to take the y-intercept, we're going to make the x equal to 0. So we get 0 squared minus 0 all over 0 plus 1, so 0 over 1 or 0. So when x is 0, y is 0. So my y-intercept is going to be the origin right here. Okay, now notice that's also my x-intercept. Now I don't know if I have another x-intercept, and so not assuming that, let me just go here. My x-intercept, I know I'm going to make the entire equation equal to 0. So I get x squared minus x over x plus 1. I'm going to multiply both sides by x plus 1. And when I multiply both sides by x plus 1, I get 0 equals x squared minus x. Again, remember, I'm solving, so I'm going to factor this out. I could have just factored it out before, x minus 1. And I know that x is 0, so that's 0, 0. And x is 1, which means my two x-intercepts are these two. I could have also already looked at the factored version here. Remember that, again, our x-intercept, when you have these fractions, our numerator cannot equal 0. So what values make the numerator equal to 0? Well, that would be 0 and 1. And I could have figured it out that way. But either way, I now have my x-intercepts. And so I know that I have another x-intercept here at 1, 0. Now, if I go to my graph, I kind of already see how the wave looks. What you're going to notice, at least in my graph, and I don't know yours, my table goes up by ones. And so it's very difficult to figure out, like when x is 0.5, where's my y value? And so, again, that would be something that you might want to change the value on your tables to kind of reflect halves, or you could go to the calculate feature. Like, for example, when x is 0.5, y is negative 0.16, okay? And so I know it's down here. So it gives me some indication. Then I might try, well, what about negative 0.5? So if I go to my calculate feature again, right, I'm going to go, and when I calculate negative a half, I get a y value of 1.5. And I start to realize, oh, okay, my graph goes up this way. And again, if I went, let's say I go to my table again, and I look at x is, let me go to like a bigger number, x is 3, I get 1.5. So it's, again, over here. And so I realize, it's not a great graph here, but something like that. Okay, so again, it's a little bit difficult sometimes, and you might have to zoom in or you might have to change your scale a little bit, but the big picture is there. You have your x-intercepts. There's no holes, so I don't have to worry about that, but that's the general look appearance of my graph. And then I do the same thing again with the other side. So again, if x is 3, I had 1.5. So let's say if I go to the negatives now, and I do, for example, if x is negative 2, y is negative 6. So negative 2, 1, 2, 3, 4, 5, 6. Let me do another one. Let's do if x is negative 4, it's negative 6.67, so negative 4. So 1, 2, 3, 4. And it's a little closer, and so you're going to realize that it's going to be something like that, and it's going to go closer to that. And again, it's just a general idea. You want to have, a couple of points on each side and follow the general wave. All right, a couple more, and then we're done for today. So again, we do the same process every time. First, we're going to simplify x minus 2, x plus 1, all over x minus 1. Nothing is repeated, so there's no holes. Okay, my vertical asymptote is going to be x minus 1 equals 0, so it's going to be x equals 1. My horizontal asymptote, again, it's squared and 1, so my top one is greater than my bottom one, so there's going to be no horizontal asymptote. Okay, and I know I have to divide the top by the bottom to get my slant asymptote. The only time you're going to do this is when the top exponent is 1 unit greater than the bottom. If that was like x cubed and the bottom was x to the first, you wouldn't be doing this. But again, all the ones we're giving you are like this. So again, you're going to do x. You get x squared minus x minus plus. These cancel. This cancels actually, bring down the minus 2. And you realize then it's going to be x plus 0, right? And that's going to give you whatever. But at that point, you have your mx plus b, right? So your slant asymptote is y equals x plus 0, or just the line of y equals x. Okay, so again, let's draw these asymptotes so they make a little bit of sense. My vertical asymptote is here at this line. This is the line of x is 1. My slant asymptote is the line of y equals x. So it goes through the origin, has a slope of 1. It's just your basic line. And this is my slant asymptote, y equals x. And so again, now I'm ready to find my intercepts and keep going from there. So when I'm finding my intercepts, remember that again, to find my y-intercept, I'm going to make my x's equal to 0. So I go back to the original for this one. If I make my numerator equal to 0, all the x's in the numerator equal to 0, I get minus 2. All the x's in the denominator equal to 0, I get minus 1. So that gives me 2. So I know my y-intercept when x is 0, y is 2. And my x-intercept, again, I make my whole thing equal to 0. And again, I'm going to use the factored form for this one because it's a little bit easier. So the whole function has a value of 0. And I can either multiply both sides by minus 1, but what I'm going to realize is that my numerator cannot equal 0. Anytime my numerator equals 0, my whole function equals 0. So I just need to find the values that make my numerator equal to 0. And that's going to be x is 2. So that gives me x-intercept of 2, 0. And x equals negative 1, which is negative 1, 0. And so here are my two x-intercepts, and here's my y-intercept. So again, I come over to my graph. My y-intercept is 0, 2, and my x-intercept is 2, 0, and negative 1, 0. And I know those are my main points, and now what I'm going to do is just go to my calculator and plot a couple extra points. So let me do, for example, negative 4. When x is negative 4, y is negative 3.6. So 1, 2, 3, 4, 1, 2, 3. It's about here. So what you notice is this side of the graph is this really wide graph like that. And then I'll go to the other side and I'll do the same. So I already have x is 2, so let me do x is 3, where x is 3, y is 2. So 3, 2 here. And then let me do, I probably would have to calculate here. Maybe instead of, let me do 1.5. So I'm going to go and I'm going to calculate a value when x is 1.5. And I'm going to get that y is negative 2.5. So when x is 1.5, y is about here. And then you realize, okay, this is what it looks like. So again, know how to calculate your own values because I think that's helpful sometimes for you to really be able to get an accurate graph. Okay, last one for today. Same process again. We're going to simplify it. It's already fully simplified. So holes, there are none. Vertical asymptote is going to be x equals 0. Horizontal asymptote, notice I have an x squared and I have a 1, so there's none, but there is going to be a slant asymptote, and that's going to be 3x squared plus 0x plus 1 divided by x. I'm going to get 3x, so that's going to be 3x squared, subtract, bring down, I get a 0x plus 1, so I know that's 0, right? So my slant asymptote is y equals 3x plus 0, or just y equals 3x. So there's my slant asymptote. Let's just keep going here. Let's do my x-intercept. Remember, the whole thing has to equal 0, 3x squared plus 1 over x. And again, I know that it's my numerator. If I multiply both sides by x, I'm just going to get, notice it's just 0 equals the numerator, minus 1 equals 3x squared, divide by 3. And notice I'm going to get x squared equals negative a third. So this is going to be an issue, right? X is going to be plus or minus the square root of negative 1/3. This is going to be an imaginary line. And so again, there is no x-intercept here. So I have no x-intercept. So then I go on to my y-intercept. And again, remember the y-intercept, you're going to set your x equal to 0. And I'm going to get 1 at the top. I'm going to get 0 at the bottom. And my y-intercept is undefined or none. So again, this I'm going to have no x-intercept, and I'm going to have no y-intercept. So let's go and look at what these asymptotes look like to try to figure this whole thing out. Notice my vertical asymptote is the line of x equals 0, rather. It's over here. So the y-axis is my vertical asymptote. So that makes sense that I have no y-intercept, right? So there. And then my slant asymptote is 3x. And so again, the line of 3x would be something like, if x is 1, y is 3, -1, -3. And it's going to be this line here that connects this like this. Okay, and so this is my slant asymptote. It's the line of y equals 3x. And so, again, now we got to figure out where is our graph going to fall. So this is where now we have no x-intercept, no y-intercept. So I'm assuming my graph is going to be in here and in here, right? Because that's not going to touch the x-axis or the y-axis. But let's see what it ends up looking like. And again, when you go to the graph, you realize that, yeah, those are the areas. And, you know, the asymptotes are not always visible on the graph. I see the vertical ones, but I don't see the horizontal ones. And a lot of times where you find your asymptotes, obviously, is in the table. You find the errors there. But anyway, so let's just plot a couple of points. Again, I'm going to have to calculate some values in here. When x is 1, y is 4. So I'll start with that. So when x is 1, y is 4. So 1, 2, 3, 4 right here. When x is 2, y is 6.5. So it's around here. So I know it goes like this. And then if I just do, let me try -0.5, right? Let me try not -0.5. Let me just try 0.5 and calculate that. So value, I do 0.5, and I get that y is 3.5. So 0.5 and 3.5. And so again, if I just kind of go, I know it's going to look something like that. And then I do the same thing in the negatives. So if I do -0.5 and I get my y value there, I'm going to go here, calculate, enter. Let me do -0.5. I get -3.5. So -0.5 and -3.5. So somewhere here, if I do -1, I can get that one right off the table. I get -4. So -1 is -4. And again, my graph, not great, but looks something like that. And it's enough, okay? Again, just list a couple of points off the table to show me that you understand the curve. Maybe you have to calculate some with the fractions or the decimals. Show me my vertical and horizontal or slant asymptotes, okay? And my x or y intercepts if they exist. So there's a lot of calculating to be done before the actual graphing occurs. The calculator can help you get an overall idea of what it looks like, and then from the table you can get the specific values. But that's how you graph irrational functions, or how you graph rational functions.